Okay, so welcome to the eighth talk of the Chromatic Seminar. Today I'll be talking about Lubin-Tate theories. Yeah, it's just it'll just be a brief talk where briefly talk about the Lubin-Tate theorem and its proof, and then of course of that I will introduce Morava E-theories. So we have seen Morava E-theories. I believe in Morava E-theories a little before peptides, but so yeah, this is a good step in our understanding of numeric phenomena. Right. So is the answer like the plain simple. So first I'll talk about the basic setup, few things that we'll introduce, few other things, then I'll state the Lubin-Tate theorem, and then some details of the proof, like all of the details. So again, they can download the reference in these notes, and a version of Lily's course notes by Chris. Right, so so far, a few things that we've already seen. So okay, so we're beginning with the first part, that is the setup. So far we've seen that the moduli stack of formal groups, but it admits a natural stratification with open strata. So right. So the moduli stack of formal group. So we've seen that it admits a natural stratification of open strata. So yeah, so okay, I would say height to Q, which are like locally closed substacks that classify formal groups at height exactly Q in this case. So Lubin-Tate theory is basically just a deformation theory around these strata. So that is the idea. So okay, so a few things that will fix for some notation to fix for. So K is a perfect field of characteristic B, and so there's a format of height Q over Q. So it was defined just thickenings. So infinitesimal infant thickening. So this is the part of the set of the field K is an commutative ring, so is some say R. So it's a commutative ring with a surjection. So such that if some naming the kernel of this map to be say so this may not be a good notation. Some actions says that if we denote the kernel of this map by R, then the portion of finite dimensional vector spaces over Q, sorry, K. functions. The ideal of our source. So should be necessary. So now, okay, so after this, so now you're in a position to define deformations or the mean by deformations. So maybe I haven't said this before, but so Lubin-Tate theory is you can trace it back to philosophy theory actually. So yeah, so I think there are more concrete questions that so that we use how we kind of use Lubin-Tate theory to work with, but yeah, we're not getting into that. So it's a very arithmetic. Yeah. So, hey, so suppose this infinitesimal thickening of a fluid. Okay. So then a deformation over R is a form of say okay, something F sub R over R with the image of this man. Form equals over R. Form equals over K being translated into F. So that's sense, right? So okay, so deformations over TF, okay, so they're said to be isomorphic. And first the series H of third going to not to do. Hey, so okay, so maybe some sort of a knot. So okay, so first let me define this.
Sorry, so once again, two deformations are the same if they differ by an invariant series.
An invertible
Oh,
policy.
an invertible series.
Yeah, I'm sorry.
An invertible series without a free term, or what is the condition on H of t once again?
Such that it is congruent to T modulo AR, and this AR, we call that this AR.
Yeah, okay, I see. So after reduction, it's just, yeah, I see. So all the higher terms comes from infinitesimal part. Okay.
Yeah, that's right. So yeah, sorry if I was clear on that. Anyways, okay. So right. Okay, so first let me define. So some notation maybe. So this is may not be the best notation. No, stick with this. So this is the collection of isomorphism classes of deformations of F over R, right? Yeah. So okay. So now with a now. So it looks to be a cuboid. naturally, because of our structure. But we'll see why it forms, and actually it's discrete or in a way like it is a like a set. So if it is a so what do I mean by that? So that means that okay,
I'm sorry, I didn't quite get this. What is RDEF once again?
so it is the collection of isomorphism classes of deformations of
The collection of isomorphism classes of deformations for all formal group laws over.
yeah.
Okay.
Right. So yeah, it was an arbitrary. So okay, so when I say it is a set, so that means that so if we have a deformation again f over r, sorry, fr is a deformation of f over r, right? Then automorphisms of that are identity modulo again say r, right, are trivial. So right. So okay, maybe sketch up. Yeah, there are a few things that I find we are very ambiguous in those terms, which I would also want to have a chat some point after the talk. So okay, so suppose this is about so suppose it is an automorphism. So we'll use induction actually. Induction. Sure. P. So we're using induction on P, right? So the base case is trivial, right? So I'm not getting into it. So like if n is equals to 1, then dt is equals to t, right? So suppose, so this is the induction hypothesis. Okay. Then suppose Z is the algebra that classifies automorphisms of a power. Right. So like we have two automorphisms, right? The identity and GT, right? So the way we have assumed it. So this looks something like this. So remember, okay, oops, that's a mistake. This should be a Q. Sorry. Yeah. Okay. So the goal is to show that like these are to be here, like these match. So by these I mean the two automorphisms that we would have. Like there's the identity and GT. So we want to show that they agree here. So okay, sorry, just yeah. So okay, suppose those okay, suppose these are like 5 and 5 star these automorphisms, right? So then phi minus 4 star. So it is so it is R linear because both of them are R algebra homomorphisms. So okay, so first this is a derivation of Z. Okay, so this is Z. Oh yeah. So it's the R algebra plus of an automorphisms of epsilon into what is this? Yeah. It's point out something about right about it. So, so as again, so this, I'll just say this. So because these are like our algebra homomorphisms, we know that phi minus phi dash is so it's linear. So when I say linear, so that will mean that linear. So which means that we have a following factorization. So J, so remember we zero define B as follows. Okay, yeah, I need a second for some order. Just a second. Good, no? So okay, so where was that? Yeah, okay, so we have the following factorization. So the middle term that we have in this factorization, so it is precisely right. So right, yeah. So the automorphisms of F of height exactly. So we are assuming we can just so I'll have to check the rotation that I'm using. Yeah, cube. Sorry, I'm using cube. Just make sure. So yeah, there's a middle term. So it'll be a tau over k. Right. So now that would mean that. See, I'm obviously not writing out on this. So that would mean like when we say tau is like that, which is what we need. Okay. So okay. So now we have so yeah, one more thing that we need to introduce is as kind of for the setup. So that is yeah, just basically. So we'll see that this. So okay. So I'll call this LT. So this will be our Lubin-Tate train. So I'll state Lubin-Tate for a moment. Now. So and this is where like W basis observing of weight vectors. Okay. So LT is like Lubin-Tate theory. So we'll see why it is called Lubin-Tate theory. Let's start talk about the Lubin-Tate theorem. the way is kind of looking for a universal deformation. So there's a motivation. So to understand this font term context R to R depth. Right? So the way we define so is the again this is the so we showed that this is a set. So this is a collection of all isomorphism classes of deformations of form. So R. Right? Uh, right. So first we kind of so before stating the theorem and its completeness also, so we kind of build some context by theorem. So a few ideas maybe. So okay. So now yeah, so here's the main idea actually. So there exists a canonical map. Right, so with gamma being AR. So form a group law F over K. So for if F is a form of group over K, so it is classified by this map. So like in the map as resolution. So this is right. So now, so without loss of generality, we can. So okay, so this is we call that just isomorphic. Right. So without loss of generality, we can search. Right. Now, so as we have assumed F to be a form of group of height Q, so but basically it's right. Makes sense. And okay. Now so here's the main idea. So now if lambda is an arbitrary homomorphism lifting so right and carrying VI, right, then so we will get an FGL homogroup law. So F tilde will over the Lubin-Tate with image FM. And so this is the basic idea. So now we can state the one that so okay, so we have defined all of the things, most of the things. So the F tilde that we defined above is a universal deformation. So what does that mean? So that means that for all infinitesimal thickenings R of K, we have a bijection. Oops. Oh. Okay, I should maybe pause the recording for a second. There seems to be some problem. So go again. So okay. Right. So just state it below that and now okay, there are a few lemmas or rather observations. Because there is a proof that will be using for the proof. So lemma one, so maybe one. For surjective maps. So these are like infinitesimal frequencies of K, PQS. The map. Okay, this is where my notation is telling. So we have this map. So this map is a bijection. So I'm not going with this. So see, okay, so the second lemma. So the following two. If we have a surjection, so so again, these are infinitesimal thickenings of K. Then the induced map. So this is also a surjection. So okay, so again, so for the proof of the main theorem, Lubin-Tate, so it's again an inductive proof. So induction on the length of R. So remember what R is. R is yeah, so R is in arbitrary thickening. Right. So if it has length one, then since R is just a small K, so there's not a lot to be done. So see that case when the length is greater than one. So then you can choose an element. So if we can choose element, so maybe Z horizontal railroad. So this is the way to find out. So now using L1. So we'll have the following callbacks. Okay, so now right. So then we see that we have a so there's a way we can endow this so right here with a group structure. So we have an addition map. Right. So yeah, so it gives us a group structure again by the K1 by lemma 1. Okay. So then right. So then the multiplication. So from this we get okay. Sorry again. So this Z. So sure. Consistent. Josh. Sorry. So this is what I okay. So, um, okay. So the multiplication, so it gives us action and uh, and the pullback square. So the pullback square that we work. So this that gives us an embedding that is sure. So yeah, so we get a subjective in the embedding of this form. So again, so here we involve second lemma L2. So yeah, so you can see so I'm not being very complete with the details. But okay. So again, using like similar reasoning, we'll get that toss for of so okay, this is also not for so this is like my induction process. So it suffices to prove the following specific uh case. So it's suffice to the description of this data. Uh, the Bayesian. Okay, so yeah, I'm not getting into the details, so we need to construct a map thing like this. Too much one. So after we have done this, right, second, it's usually it's evident, so it's a good homomorphism, and it's a composition from distance by the way it's constructed. So that would imply polarizing injection. Okay, and yeah, for the surjectivity part, I just so yeah, we can also for the other part we have to prove that theta is surjective, and that part I currently just leave the details of that part. So then show to so that will be equivalent as well to theta dash being injected. Okay. So now, okay, now, so define Morava E-theories. So maybe a definition of the map. So the follow the Lubin-Tate and the sequence. So just maybe through below by the way constructed. Also, we have some Q as refer to the image. This is the okay. So using like a lot of things that we have seen so far. So we'll see that we can construct an even periodic spectrum like given by yeah. So it's that where this beta is order and the cohomology is very yeah, so that is basically Morava E-theories and Lubin-Tate theory. So yeah, as I'd said, I don't have much to say today. So yeah, so that'll be it for me, I guess. Thanks for listening. And so for the next we'll probably begin with the paper with the Nullstellensatz Seminar. Yeah, this one just stop. Maybe we'll join recording.